day, dear colleagues. Today we open the second day of our conference, and we have a section workshop on physics and physics education. We have 8 reports. It's different topics, different difficult, but we think that all of reports will be very excited. We have your video presentation, and the last report will be in live. And we're starting. Our first presentation has title Enhancing Student Performance through Laboratory-Based Instruction, and Yudelin Patero.
The one.
Is entitled Enhancing Student Performance Through Laboratory-Based Instruction, a study on the relative density and buoyancy of liquids. This is my outline and this is my abstract. Now, public secondary high schools in the Philippines do not have a science laboratory course that complement their lecture course, not even in the science, technology, and engineering and mathematics STEM curriculum. Besides, science equipment or apparatus is often not available. That is why teaching science can be tricky, especially when it comes to topics like how and why things float in water and other sea. Many students find this confusing even after studying it in the class. Thus, we wanted to see if doing experiments in the lab could help students understand this topic better and identify the underlying factors influencing these outcomes, which could provide deeper insights into the efficacy of the intervention. So this study answers the following questions. What is the mean pre-test and post-test performances of the control and experimental group? What are the mean gain scores of the control and experimental group? Is there a significant difference between the pre-test and post-test performances of the control and experimental group? Is there a significant difference between the gain scores of the control and experimental group? And what are the factors contribute to the significant performance in the laboratory method? So the null hypotheses are: first, there is no significant difference between pre-test and post-test performances of the control and experimental group. And the second null hypothesis is there is no significant difference between the gain scores of the control and experimental group. This study employs a descriptive quasi-experimental design, now utilizing a 20-item teacher-made test. And then the respondents are the 100 heterogeneous students in one of the secondary high school in Cantilan, Surigao del Sur, and they were grouped into control and experimental groups. For the statistical test, the paired t-test was used to test if there is a significant difference between the mean pre-test and the post-test scores of the control and experimental groups. The p-test for 2 independent samples was also used to test if there is a significant difference between the mean gain scores of the control and experimental group And we also used multiple regression analysis to determine the factors that affect students' performance in both groups. For Table 1 shows the pretest performances of the control and experimental group. As shown in the table, the pretest mean score of 13.032 of the control group shows a slightly higher value compared to that of the experimental group with 11.357. This means that the control group performed better during the pretest. Additionally, the computed standard deviation of the control group is 1.7553, which is also a little less than the experimental group of 2.0380. This implies that the scores of the respondents in the control group are more clustered to its mean compared to that of the experimental group. The table also shows the post-test performances of the two groups. The control group obtained higher post-test mean of 14.226 than the 12.821 of the experimental group. This means that the control group displays a better performance than the experimental group during the post-test. However, with a higher standard deviation value of 2.0148 of the control group, it demonstrates a more dispersed set of scores than experimental group with 1.8096. Further, this implies that there are respondents from the control group with extremely higher scores and contributed to the group's higher post-test mean scores. This findings is aligned with the work of Aulia in 2018 and Tarhan in 2010. Table 2 shows the mean gain scores of the control and experimental group. As shown in the table, the experimental group obtained a higher mean gain score of 1.4643 than that of the control group with 1.1935. This implies that the respondents in the experimental group have a better gain performance compared to the control group. Moreover, the smaller standard deviation of the experimental group 1.2048 implies a better set of scores clustered close to the mean compared to the more dispersed set of scores in the control group with a standard deviation of 1.6164. This confirms the work of Sin in 2023. The magnitude of change between the experimental and control groups is approximately 0.27, which indicates that the experimental group experienced a slightly larger improvement in the performance compared to the control group after the intervention. The experimental group received a targeted intervention. Perhaps this intervention was effective but not dramatically so, resulting in only a slight improvement. Table 3 shows significant values of the difference between pretest and post-test performances of the control and experimental group. The computed p-value during the pretest is 4.364 and has a corresponding p-value of 0.000, which is less than the 5% level significance. Thus, the null hypothesis is rejected. With this result also, it is inferred that there is a significant difference between the performances of the control and experimental group during the pretest. Additionally, the computed t-value and p-value during the post-test are 4.257 and 0.000 respectively, with p-value which is less than the 5% level of significance. The null hypothesis is rejected. Thus, there is a significant difference between the post-test performances of the control and experimental group. Table 4 shows the significant values on the difference between gain scores of the control and experimental group. As shown in the table, the computed t-value is 4.84 with a p-value of 0.000. With a p-value less than this 5% level of significance, the null hypothesis is rejected. Thus, there is a significant difference between the mean gain scores of the control and experimental group. Further implies that the experimental group shows significantly higher than scores than that of the control group. It is also infers that the method applied in the experimental group can significantly contribute in increasing performance of the students compared to the method applied in the control group. Further, while analyzing pre-test and post-test performances and gain scores provides valuable information, understanding also the underlying factors influencing these outcomes provides deeper insight into the efficacy of the intervention. The F value of 4.21 is significant at a level of significance alpha equals 0.05, which means that there is a significant relationship between grades and the factors, namely the difference in the post-test and pre-test scores, the attitudes of the students towards physics and the laboratory method, and the teacher. Specifically, since t-value for attitude is significantly at alpha equals 0.05, the variable attitudes affects the grades of the students. So observations following the laboratory experiment yielded promising results as a discernible improvement in the student performance was noted with a statistically significant increase observed in post-intervention assessment compared to the pre-test. So therefore, in the ever-evolving landscape of educational methodologies, laboratory-based instruction remains an enduring and indispensable laboratory approach, for imparting scientific concepts. So these are the references. Good day.
Okay, thank you, Judelin. Very interesting and very big experiments. Yes, you have many students for suppression. It's very interesting. Okay, colleagues and members of our conference, I am glad to see you because I can't to do it on the beginning. And I so speaker with Irina, and maybe anybody have questions. You can speak on microphone or in the chat. Or you can write a chat. Maybe you can't speak English, then you can write chat. Okay, please give your questions.
Yudelin, I have a question. We hear about your experimental calculation, but could you tell us more about experimental group, about difference in learning?
Hello. You mean the nature of the respondents?
We hear.
Okay. So, yeah. So the respondents are actually high school students in one of the public school in our province, in our town, in Cantilan, Surigao del Sur. They are the least in terms of performance, no, the least students. That's why I took the advantage of recording their performance after giving them the experiment or the laboratory. Thank you.
Okay, thank you. Are you here? No.
Thank you.
Yes. was based on the extending all students, how do students perceive and change this laboratory-based instruction on relative density and buoyancy? How students took for them give your answer? What is
Can you
their
repeat again?
relation?
In terms of performance, yeah, their performance is, I mean, I appreciate their performance, although as mentioned in the PowerPoint presentation, although the what is this? Um the the shift is I mean, the shift is slight, but it tells us in the as a whole that the students are performing better after the intervention was made.
Okay,
Yeah,
are
thank
they
you.
was interesting these experiments?
Yeah, actually,
Okay,
it is evident in their faces that they love to do it. Uh,
okay, thank
thank-
you. And we have a question from Frank Angelo. How did she make sure that those threats to validity are fixed in the experiment? In the chat, if you can see.
okay. So, I cannot
How did
see.
she make sure that those terms to validity are fixed in the experiment?
Are I
We don't
cannot see
have
the.
a question in chat because we
Yes,
have
yes, I understand.
Can you repeat it again?
Uh,
Sorry.
did you make sure that those threats to validity are fixed in the experiment?
Yeah. Yes.
Yes. Okay. Okay, thank you. Are there
Thank
any
you.
questions? Okay, thank you very much. And uh, we continue with an hour, yes? Because in Philippines now is 17 or 19 o'clock. It's very
Um,
uh,
7.
evening, yes.
Yeah,
Okay.
past 7.
You're with our for end.
Pardon?
You will with our for ends conference for end sections. Okay, we be with our. So, and next report is Ryan Jeffens and Ramon de dos Santos measurement of over the counter ascorbic acid samples optical rotation via an improvised polarimeter. It's very interesting experiment, STEM educational. Okay, thank you. Beginning.
Advisor Dr. Ramon de los Santos, and we are going to present our study, Measurement of Ascorbic Acid Samples Optical Rotation via Improvised Polarimeter for Purity Assessment. The presentation will have the following structure. We'll start off with an introduction of the problem we seek to solve and the concept related to our study. Then, we will discuss the methodology taken divided into 4 parts. The construction of the polarimeter, the experiment proper using polarimetry and melting point determination, and lastly, the post-experiment analysis. Next, we are going to show and discuss the results in the polarimetry and melting point determination experiments. Finally, we will quickly summarize and conclude our study. Emerging problems associated with drug use and abuse include adulterating drugs and different chemical substances. Drug adulteration is constantly and commonly seen where there is a decline in the purity of most drugs. To detect these adulterants, Chromatographic methods are commonly used as they have a high separation capacity to detect multi-drug components in a sampled substance. However, chromatographic methods require special equipment which can be costly to acquire and maintain. Aside from the common chemical analysis techniques available, polarimetry can be used to analyze inorganic and organic compounds. However, Breton 2015 observed that students struggle to understand the concepts due to the black box system of commercial polarimeters. With this, we characterize ascorbic acid to assess its purity using an improvised polarimeter. So what is a polarimeter? With this, we discuss a few concepts. Let's start with light polarization. From high school physics, we know that EM wave consists of oscillating electric and magnetic fields perpendicular to the direction of propagation. When light is directed through a polarizer, electric field components align in a particular direction. The electric field of the light exiting the sheet comprises solely the elements aligned parallel to the polarizing direction. One application of polarization is found in organic chemistry through optical activity. Optical activity refers to a unique property exhibited by chiral compounds like ascorbic acid, where they have the ability to rotate flame polarized light. Polarimetry is used to quantify the extent of this rotation. The tool employed for this measurement is called polarimeter. The mechanism of polarimetry goes like this. First, we have an unpolarized light source. As it passes through a polarizer, it becomes polarized. This polarized light will be rotated once it hits a sample containing chiral compounds. Finally, the angle of rotation will be measured using an analyzer. This optical rotation is usually expressed in the standard way called specific rotation, denoted by square bracketed alpha. Specific rotation is defined as the observed rotation when light with a 589.6 nanometer wavelength is employed with a sample path length of 1 decimeter and a sample concentration of 1 gram per cubic centimeter. The calculation of a specific rotation is governed by Beer's law, which is simply the observed rotation over the product of path length and concentration. When the observed rotation is expressed in this way, it yields a physical constant unique to a particular optically active compound. Breton 2015 mentioned in his study that undergraduate students struggle to understand this concept. Hence, several homemade polarimeters have been documented for student experiments. The first demonstration typically involves utilizing an overhead projector. Another polarimeter design was by Mehta and Greenbow. Breton 2015 also made his version where he used two PVC pipes. Another polarimeter design was by Bernard and Mentes featuring a 3D printed body. Furthermore, Lisboa and Sotomayor presented a laser polarimeter apparatus. In this study, the polarimeter design developed by Witting and Jusnes was used due to its advantages. First, its resolution of 0.5 degrees. Second, it requires minimal skills for a more durable setup. Third, its affordability renders it suitable for educational settings. The cost of the construction of this polarimeter is around 6,500 pesos, which is significantly inexpensive compared to commercial and manual polarimeters that cost around 644,000 and 71,000 pesos respectively. Proceeding with the four-part methodology, we start with the construction of the polarimeter, which is guided by our main reference, Witting and Jusnes 2020. The polarimeter was assembled with the aid of Lego bricks. For the base of the instrument, 4 6x16 Lego plates were connected. The fixed polarizing film was sandwiched between two Lego bricks. The LED light source was held using a 2x1 brick. The protractor was supported with 4x2 and 2x2 bricks. And at the back of the polarimeter, we can see the red LED detector. And the part that we modified in this setup is that we added a resistor in series with the LED detector to improve the detection capability of the device despite having a sample with a relatively low specific rotation like ascorbic acid. Upon constructing the polarimeter, we are now ready for polarimetry measurements. We start by preparing our samples first. Two different brands of ascorbic acid named brands X and Y were dissolved in a certain volume of distilled water such that we achieve our desired concentration, which is 0.25 grams per cubic centimeter. Before measuring the optical rotation in a dark room, the instrument was first calibrated. From this, we determined the optical zero. To do this, two detections were done: visual detection and voltage detection. For visual detection, we replaced the red LED detector with a white paper. The range of angles corresponding to the dimmest light intensity were recorded. To ensure precision, a margin of 4.0 degrees was added on either side of these noted angles. For voltage detection, the voltage reading at the midpoint of the visually detected angle range was initially recorded. Then, incremental adjustments of 0.5 degrees were made on both sides when monitoring the voltage displayed on the multimeter. The angle corresponding to the minimum light transmittance was identified as the optical zero. After calibration, the sample was poured into the glass cuvette with a known path length. To locate the new optical zero, the same method used for calibration was repeated. Then we get the observed rotation by subtracting the calibrated optical zero from the new one. Note that we added the visual detection method, which was introduced to serve as the baseline for voltage detection. To supplement the polarimetry characterization, the melting points of the samples were determined. This is done using the melting point apparatus. To start off, we prepare the sample by transferring a small amount of the substance onto watch glass. Then, we dry the sample by either oven drying it or pressing it onto a piece of filter paper. Then, the dried sample was introduced into the capillary tube. After that, we place the capillary tube to the sample holder, as shown in figure 12. To operate the apparatus, a target temperature of at least 10 degrees Celsius below the expected melting point of the sample and a gradual ramping rate of 1 degree Celsius per minute were set. Finally, the melting range was recorded. This is simply the temperatures at which the samples began melting and completed melting. To analyze the observed rotation for the 5 different path lengths used, the specific rotations were computed. This is done using the equation below. Then for the analysis, the calculated specific rotations were compared to literature values. Note that ascorbic acid has a specific rotation of 20.5 to 21.5 degrees. On the other hand, from the melting range as recorded from 3 trials, the average melting point was calculated using the minimum and maximum values of the melting temperature range. Then, this was compared to the theoretical melting values. Note that ascorbic acid has a melting range of 190 to 194 degrees Celsius at which it also decomposes. If the values are close to the theoretical ones, we will conclude that the sample will likely be pure, otherwise it is impure. Now we proceed with the results of our experimentation. Table 1 presents the calculated specific rotation values derived from the observed rotation. Note that from the literature, the specific rotation is derived from the observed rotation when a light source with a wavelength of 589.6 nanometers is used. However, the peak emission wavelength used in the experiment is 592 nanometers. Therefore, the values obtained are expected only to be close to the literature values. From the measurements for band X, the percentage error is relatively low, averaging 4.76%. Conversely, for band Y, the percentage errors range from 23.8% to 52.4%, with an average error value of 41.2%. Here's a scatter plot of the observed rotation versus path length for bands X and Y. The plot of band Y deviates noticeably, which can be attributed to some impurities. Note that the slope represents the specific rotation divided by the concentration. For band X, the slope is 5.23, resulting in specific rotation of 20.9 degrees, which is within the range of the theoretical specific rotation. Meanwhile, for band Y, the slope is given as 3.50, corresponding to a specific rotation of 14.0 degrees, which is outside the expected specific rotations. Therefore, band X is suggested to be pure, while band Y is impure based on this polarimetry experiment. In melting point determination experiment, we see that the average melting point of band X falls within the theoretical value. Furthermore, the observed melting range is narrow. Conversely, the average melting point of band Y significantly deviates from the theoretical, and the observed melting range is broad. This suggests that band X is pure, while band Y is impure, which is both consistent with our result in the polarimetry experiment. In summary, this research used an improvised polarimeter to measure the optical rotation of ascorbic acid in order to assess their purity. This primary characterization method was supplemented by melting point determination. Here are the summary of the results for polarimetry. Here's for the melting point experiment. And in conclusion, band X is likely to be pure, while band Y is likely to be impure based on the two characterizations done. This comprehensive approach combining polarimetry and melting point determination proved to be cost-effective compared to other devices. This offers a practical and accessible solution for purity evaluation. Furthermore, the non-black box nature of the polarimeter facilitates a straightforward demonstration of optical activity and polarization concepts. Here are the references we use in this presentation. And that's all, and thank you very much for listening.
Okay, it's very interesting. Small experiments, but it's very big national, scientific, and it's a modern STEM educational Lego, yes, for children. It's very, very close for children for students. Thank you. And are there any questions? Okay, there aren't. you in your experiments you use for ascorbine, yes?
Yes.
Are any other methods, other water, maybe color water? Do you use or not?
Pardon, can you repeat? Sorry.
Do you use other water, other maybe color water? To other, not ascorbine.
To dissolve the
Uh,
sample, we actually, go ahead, sir.
Sige. Yes, Ryan, go ahead.
To
Okay.
dissolve the sample, we used distilled water only. And in other way, it is also applicable with other samples. Like in my thesis, undergraduate thesis, we did it in a sodium ascorbate, which is uh, yields also a better result compared to ascorbic acid because it has a higher specific rotation.
Yes, I see. Why ascorbine?
Primarily, we use ascorbic acid because it is one of the health supplements prominent during the pandemic, when
Oh,
the study was being conceptualized.
yes. Okay, okay. Now I understand. Okay, thank you. And you use Lego, yes?
Yes.
Do they very useful? Or I understand it's very popular, yes, it's very comfortable, but I think it's not very closely to the experiments. There are many mistakes, a lot mistakes, or not?
Actually, the Lego gives some advantages. For example, it offers much flexibility and compared to just measuring the length and etc. Because it's also durable and portable in such a way that we can carry the polarimeter and do the experiment in such in the other room.
Okay, I understand because for polarimeter, it isn't in a school program. In Ukraine school, these themes study, but very, very small. And students don't understand what is. And it's a useful work, but in our university, not school, university, we use the telephone, phone ecran for phone, or if it only ecran, a display, or something other materials, but not Lego. Okay, we won't use your experiments in our university. Thank you for your work. And maybe there are other questions in the colleagues. Please speak. Okay, I would like successful in the future work, and maybe anybody, but not anybody, all body read the article. It's very, very useful. Thank you. And we go to the next report. The next report, George Kalimons, Michel's in, I am sorry, Ionov, Panadotics Panadots, and others, that transformation of children's mental representations of 5-6-year-old for coagulating preschool's models through solid approach. Okay. Thank
Okay,
you.
so hello to everybody. My name is George Kaliampos, I hold a bachelor degree in physics and a PhD in science education. And today I will present you the study, the transformation of children's mental representations of 5 to 6 years old for coagulation, precursor models through a storytelling approach. We did this study with our team, which is aparted from Michalis Ioannou, a PhD student, the assistant professor Panagiotis Pantidos, and the full professor Konstantinos Ravanis. First of all, I would like to express my many thanks to the committee that give me the opportunity to participate in this conference, and of course express my warm greetings and feelings to all the Ukrainian people. So I am from Greece, our team is from Greece. You can see here Greece is located in the south part of Europe, and it has almost 10 million population. Our capital is Athens, and half of the population live in the capital. We are almost 1,400 kilometers from Kiev, and I live and work in Patras, which is the third biggest city in Greece. It is 220 kilometers from Athens, with a population around 170,000 citizens. We are a quite big port regarding Greece, and we have in Patras the University of Patras, where I live and work. So here you can see some photos from my city, the port, the city center, and the university. So now let's start with the study. The last decades, constructivism has dominated science education. And at the core of this theory lies the alternative ideas. Alternative ideas hold their origins from both the natural world and the socio-cultural world. An example of how alternative ideas come from the natural world is if the fact that a tile feels colder than a wooden table, for example. Or another example that shows how alternative ideas come from the sociocultural world is the fact that many children quite often hear expressions like close the door so the cold doesn't get in. Within early childhood science education, the precursor models seems to play a key role in the last years. Precursor models are actually cognitive entities which interpose themselves between the original children's representation and the scientific models used in education, and actually they allow pupils to put forth thought processes that surmount the obstacles of their thinking, and they are compatible with the scientific ones. So, what we did in our study was that we did an experimental investigation, qualitative in nature, and it was aparted, the study, from a pre-test, a teaching intervention, and a post-test. We carried out individual semi-structured interviews, and the sample of our study was 99 children aged 5 to 6 years old. The aim of the study was to answer the following research question: to what extent can a storytelling intervention help children 5 to 6 years old construct a precursor model regarding coagulation? So here you can see the three tasks that parted the pre-test and the post-test. In the first task, melted butter in the cold air, the children were shown a piece of butter that is melted on the flame of a camping gas, and were asked what would happen if in the melted butter if we let it outside in the cold night. Regarding the second task, melted butter in the fridge, again the children were shown a piece of butter melted on the flame of the cabin gas, but now they were asked what would happen in the melted butter if we place it in the fridge. And in the third task, melted chocolate in the cold air, a piece of chocolate was melted on the flame of a cabin gas, and the children were asked what would happen in the melted chocolate if we let it outside in the cold night. The teaching intervention was based on a storytelling approach, and the story that was told to the children took place in a house located near a lake during a very cold winter. And actually, the parents of a disobedient child had forbidden him to take the boat in the cold afternoon and go for a ride on the lake, but the child disobeyed them and secretly took the boat. The water froze in the lake, so the child stuck there. The parents searched for him, and when they found him, they melted the ice with fire and unstuck the boat. And when they asked him why he did this, the child in the story answered that he did not believe that the air in the lake around the boat would be as cold as the refrigerator to cause the water to freeze. So the narrative was dialogic and interactive, and the emphasis was given on the relation between the cold air and the refrigerator. The results were classified into three distinct categories: sufficient responses, which were those that were compatible with school scientific knowledge; the intermediate responses that were characterized by some kind of shortcomings or contradictions; and the insufficient responses that had nothing to do with school scientific knowledge. Here you can see in the table the results and some indicative results. I will just tell a few of them. In the task 1, for example, a sufficient response was that the butter will become hard again as it was before we melted it in the fire, as it will cool down during the cold night. In the second task, an indicative insufficient response was that in the fridge it will stay the same. And regarding the task 3, an intermediate response was that the chocolate will freeze during the night. Your throat will get cold when you drink it in the morning. So, what we found was that children 5 to 6 years old face great difficulties in conceptualizing coagulation, but the storytelling approach has had a very positive impact on children conceptualizing coagulation. And after the intervention, the vast majority of them were able to associate cooling with coagulation. Quite interestingly, in task 2, almost 76% identified the refrigerator as an appliance that causes melted butter to coagulate. So the function of a refrigerator begins to act not only as a familiar cooling, preserving storage space for food, but also as a system that is involved in thermal exchanges. So the consistency of children's reasoning found across all tasks in the post-test supports the view that early childhood children are capable of constructing a precursor model regarding liquid coagulation. And in the heart of this model lies the concept that the wider environment acts as an appliance that has analogies with the refrigerator. It should be noted here that this precursor model does not include the mechanism of interaction between hot and cold systems, for example, the issue of thermal equilibrium. And this is why we called it precursor model, because it is between students' ideas and the scientific model. Some study limitations is that it is, of course, a small sample, and the fact that the approach was confined only into the usage of familiar materials. Further research could be done regarding the studying of the stability of the precursor model through quantitative approach in a much more large sample, and through the comparison of children's reasoning between familiar and non-familiar materials. Thank you very much. And here is some indicative reference of the study. Thank you again.
Thank you for your efforts. And I think I wrote your paper, and I think
Yeah, hello to everybody now for real time.
Hello,
Hello.
Irina, microphone.
I think that very useful for children because this topic very difficult, but you give knowledge from very
Early age, yes.
yes,
Thank you very much. Thank you very much.
and thank for geographic parts.
Okay.
Yes, geography part is also interesting, very interesting for all also, because it's very from Ukraine, and
And today we have authors from not only Ukraine. From
Yes, I know. I know. This is the why I did this, and I like to see other from other countries, other people, all over the world.
yes. Today is from many countries, and really your work is useful. But why you beginning work with small people, small with child? Because okay.
Yes. Okay. So actually, the goal of all the teachers is the students to grasp the scientific ideas. So what we are trying to do now, as I told in my presentation, is that from so early age, it is a good point the students to get a precursor models, which later will become to scientific knowledge. So instead of trying to go from alternative ideas, which are not compatible with scientific knowledge, to get to the school scientific knowledge, there is a step in between, so that the student will go from alternative ideas to precursor models in this small age, and then later from precursor models to the scientific ideas. So it is actually giving them a step. I don't know if you understood me.
Yes, I see.
Yeah.
I understand.
Okay. Thank you.
Thank you. And you, it's really in the today. It's very task of many teachers, many pupils, because children have many knowledge, but they can't thinking. They can't analyze it, what they know. They can't analyze it information. And physics, they don't know, don't analyze from the nature. From it is very big task for the children, for the teacher. And of course, we must study with small and smaller, yes.
Yeah.
Okay, thank you very much. Are there any questions? Maybe who has also working? Okay, Raymond, please.
Yes, thank you. Thank you, Professor George. I'm curious about the children's story. So uh, did the story itself originated from Greece? And are there other stories
Yeah,
like that that is directly related to science?
yeah. Okay. Thank you very Yeah, okay. Thank you very much for your question. Actually, the story, in Greece, there are many stories about lakes, about forests, and this kind of stuff. So we generated the story, but we were inspired from locals, from local stories that are around. And they can grasp children ideas because in storytelling approach, the purpose is to grasp the children's to grasp children's attention. So yes, so actually we generated, but inspired by general stories.
Okay, yes. Thank you, Professor.
Thank you very much too.
We have a question from the participants. How did the author ensure that ethical research on children's ethics was met?
Excuse me, can you tell me the question again, or it is written? Yeah, how can?
How did the author ensure that ethical research on children's ethics was met?
Ethical, you mean that they may feel afraid or something like this by the story? What ethics? Can you explain me a little bit the
Maybe
question?
ethics research
You mean
from
ethics from the
ethics.
point of
Yes.
ethics from the point of view that they may feel scary or something like this.
Maybe.
Yeah. Okay. It was a storytelling approach. It was not in a frightened environment, and of course, each child's take it with his or her own way. But with there, I don't think I can see that. Yeah.
Yeah.
Yeah. It was not something more specific.
Okay. Okay.
Okay. Thank you very much.
Yes. Thank you. Thank you. And you? There may be your report was interesting. There are many questions, but maybe there aren't. There are here. No. Yes. Okay. Thank you.
Yeah. Thank you too.
Stay with me. Yes. Stay with stand with us, and we next report is Francangelo Pacalo, practice of terminal velocity and energy of Pacislu, a video analysis for physics classroom experiment.
Good morning to the audience and participants of the ICON MaSTEd 2024. I'm Frank Angelo A. Pacala from the Philippines, but currently I'm working as an expatriate teacher in the Presidential School of Uzbekistan in Karshi City, Uzbekistan. So may I introduce to you my research title. This is the Tracking the Terminal Velocity and Energy of a Parachutist, a video analysis for physics classroom experiment. So this experiment was conducted in my school inside the classroom together with my students. So a common issue in the classroom is the experiment on terminal velocity, because this is a very difficult experiment, and falling bodies we can measure the time of the fall, but it will be difficult to measure its velocity. Where will the like for example, where will the resultant force will be equal to 0, wherein the weight and then the air resistance will be equal. So considering that there will be a lot of the different uncertainties in the measurements of the velocity, or even with the time with the use of the stopwatch. So there will be like the human error, random error, with the use of the stopwatch, the ruler. So the presence of air resistance can also cause fluctuations in the velocity of the object being dropped, affecting the accuracy of the results according to source number 15. So most teachers will just escape the experiment on terminal velocity and only doing some theoretical explanation about this topic, and of course mathematical calculations. So in this experiment that I did, I used the tracker, video analysis, and tracker video analysis and modeling to help reduce these measurement uncertainties. So the tracker video analysis is a software that allow users to track and analyze the motion of objects with the video according to source number 8. So the software uses algorithms to track the position and the movement of the object over time. So the objective of this research is to determine the terminal velocity of different masses of the parachutists, determine the relationship between terminal velocity and masses of the parachutist, and check if this is according to literature correct, verify the generated kinetic energy versus time graph and potential energy versus time graph from the literature, and determine the classroom implications of using tracker video analysis on freefall experiments as cited in the literature. So basically, this experiment is about the masses. The independent variable is the masses, and then the terminal velocity will be the dependent variable. And taking a look at this, capturing this in a video and uploading in the tracker video analysis and modeling. By that, I can generate a graph, taking a look at the terminal velocity, the kinetic energy, and then the gravitational potential energy, and verifying this according to the literature. So for the theory, we know that the resultant force of a falling body will be equal to the weight minus its drag force. So the drag force, according to literature, is equal to 1/2 times the drag constant CD, the times the velocity squared times the cross-sectional area. At some point, the air resistance becomes equal to the gravitational force. So, and the object no longer accelerates, and then the velocity will be constant. So at this point, since the drag force and the weight is equal, so we can equate that the weight is equal to that 1/2 CD rho V squared times A. So according to source number 23, if we will solve for the velocity, it will be square root of 2 mg. So that mg came from that W over CD rho times the area. So now I am concerned here with the masses as the independent variable. So if we will plot mass, square root of mass versus the velocity, the gradient will be square root of 2g over CD rho times A. So from that, actually we can calculate the acceleration due to gravity, which is the g from that particular instance. However, in this result, it was not my objective. When I tried calculating the g, I found out that I was deviating from the true value of j. It's because even if this experiment reduces the error, still the value of g I cannot calculate. That means I need to try again this experiment. So that will be one of the limitation of this particular research. So the materials, so as you can see on the picture, the material includes a retort stand with clamp and a boss, meter ruler, masses, do-it-yourself parachute made from cloth and thread. And the masses, I have 6 pieces of masses. So this is the tracker. This is the interface of the tracker. Obviously, I have already uploaded the video here. So what if you wanted to emulate this experiment, what you need to do is to capture first the video of the parachutist falling with a ruler here. As you can see, there's a meter ruler. This will be the source of measurement for the tracker. So you need to take a video first from your mobile phone, upload it here, and then you can now capture this kind of masses versus the y-axis, masses versus the y-axis. And as you can see here, there are different measurements like the time, the x-axis, length, and the y-axis length, because you know this is moving in a two-dimensional, so there will be length, and then there will be, there will be y-axis and then the x-axis. So you can also have here, if you click here, this green up arrow and down arrow, you can have the energy and some other physical quantities. So these are now the results. Sorry, this is the results. So as you can see, this is now the terminal velocity, displacement versus time. So the terminal velocity based from the tracker is this parameter A, which is about minus 1.36 plus or minus 0.01 meter per second. So where did I get this value? I get this value by creating a tangent line from here. So what I found from the graph is that it is having a straight line at this point, more straight line at this point. So I consider this as the terminal velocity of the object. So I collected this different terminal velocity by adjusting the masses, by having different masses, and this is now the data in table 1. So the masses are there from 32 from 0.032 kilograms to 0.132 kilograms. So in your experiment, if you will emulate this, you can extend the number of masses. So the terminal velocity of this is recorded. So this is considerably correct, because based from our equation here, if this CD, rho, and area are constants, and the G obviously is constant, there is a direct relationship between V and M, a square root of M. So in this table, we can see that we have verified that equation, that if the mass is increased, the terminal velocity also increased. So therefore, if we will graph that, I graph this in Microsoft Excel. So we have this kind of graph. A line of best fit was generated, a straight line of best fit. So this graph now verifies our equation, that indeed there is a direct relationship between the terminal velocity and then the mass, as far as equation number 4 here is concerned. So the energy of the parachutist are also shown in the picture. So we can just click on the tracker energy. You can choose kinetic energy or GPE. Now, if you will look at some books and researches on the internet, you will see that the GPE of a falling object is decreasing while the kinetic energy is increasing. So these graphs that was generated from the tracker verifies the theory from the books and from related literatures. So in conclusion, this experiment proved that the tracker video analysis can determine a parachutist's terminal velocity and energy. The data on terminal energy versus the square root of the parachutist masses were consistent with the theoretical perspective. So the straight line of best fit in figure 6 proved this hypothesis. The gravitational potential energy, kinetic energy, and total mechanical energy were consistent with the literature. However, The TME graph was not consistently constant because the work done by the air resistance was not considered. I did not show this in the picture. So the TME was not entirely constant. That means if you wanted to do this experiment again, so you need to add more data, and from that data take the average, and you can have a more constant total mechanical energy. So what is the gist of this experiment? The implication is that we can also do some experiments on the terminal velocity, not just doing some theoretical explanation and calculation inside the classroom, but we can also prove this theory by doing this simple experiment. Yet it is very intellectual for the students to learn these things. They will have some aha and wow moments when they have found out that what they are doing theoretically is also applied in a real life situation. For example, for this one, having some kids toy like a parachute, a do-it-yourself parachute, can also verify some physics experiments. So that's all from my end. Thank you for listening, and thank you for your attention. And again, congratulations to the Icon MaSTEd 2024 participants, as well as the hosts and management of this event. Thank you so much and have a great day ahead.
Thank you. We are glad to have a good day, you also. And it's very really interesting work because in the experiment does not theoretical, and we must do experiment and for students it's very important to explain and have a practical and say what why not result of theoretical and experiment are equal. Okay, thank you. Do you have students in your experiments? Is it students of university or of schools?
Hello.
Hello, hello. Thank you
Dobry
for
den. Dobry
Yes.
den.
Добрий день.
Chut paruski. I'm sorry.
Okay.
So in that experiment, there were students of mine who were helping and making the parachute. So these are high school students, not university
Okay.
students. High school students, grade 8.
Yes, because when such experiments give for small children, they say, "Oh no, your physics laws are not equal, are not right," because we have many mistakes. But it isn't mistake. It isn't. Opportunity of air. Okay, thank you very much. And are there any questions? Please, dear colleagues, dear participant. Okay. Do you change the parachutism size of parachutism? Size of
No, that it's constant. The only one being changed is the masses. So the length, what's this? The area of that plastic, that packet is constant.
Okay, I understand. Because it's very interesting, maybe the round level from the size.
Yeah. It can also affect based from the equation. Now, if you wanted to emulate with your students inside the classroom, so you can also have the independent variable as the area of the parachutist, and then the dependent variable will be the terminal velocity.
Yes, because but Science students understand. There are
Yeah.
dependent, but math don't understand. Okay, thank you. And it's very important for energy. And you used video, yes?
Yeah, video was taken and then it was uploaded in that software tracker. It's very useful. Even my elementary students, grade 6, know how to use this tracker because I'm
Yeah.
using technology integration mostly in the classroom.
Okay, it was a special digital, special video or special program or special Apple on the mobile when you use video.
No,
In
you
which
just use your
program?
camera. Just use your camera.
Camera
Camera video.
phone or special camera?
No, not special camera, just normal camera in your mobile phone, smartphone, and then
Okay,
open the
okay.
tracker, then upload it there. There are what's this? There are many tutorials in YouTube that will lead you how to use this software.
Okay, I see. Thank you. Because it very interesting and modern phone give a very, very good picture and very
But the tracker is not found on it's not an application in a mobile phone. It's a software that should be what's this, installed in a computer. Yeah, it is free. This tracker software is free.
okay. Yes, it's very
Yeah. If it's free, it's good. Let's not buy. Let's just
Okay.
use free things.
Yes, and we have question in the message in the chat. Is this okay? Your answer is a software of or app free? Yes, you say.
And we have next question. Can you share us your?
Yeah, I share it in the comment section. That's the website where you can install this software, the tracker, video analysis and modeling. It's available for what's this? iOS and MacBook, and what's the other setup computer? Windows.
Okay, Windows MATLAB. Okay. Thank you. Okay, are there maybe other? Okay, thank you, Frank. Work is very interesting and it's very useful for other. And I see we repeat your experiments also in the class.
Yeah, please do. Please do. And the
Okay.
students will be amazed.
Yes, thank you. Thank you for your
Спасибо
report.
вам
And
большое. Спасибо вам большое.
будь ласка. Так, and next.
Excuse me, may I speak in real time?
Okay.
Greetings, esteemed participants of the conference.
I scanned out. Yes. Next.
I have a demonstration. I have a demonstration. I have a presentation and I want to speak in real time. Good afternoon, esteemed participants of this conference. I'm deeply grateful for the opportunity to share with you the results of my research endeavors on the topic of rapid foresight information technologies in physics lessons. My name is Aygerim Abdullaeva. In the ever-evolving landscape of education, the question of what defines an effective teacher becomes increasingly pertinent. Gone are the days when rote memorization and passive learning sufficed. Instead, we find ourselves amidst an era that demands innovation, adaptability, and a profound understanding of the dynamics shaping our world. And the effectiveness of the education system directly depends on the quality of pedagogical activities. These words encapsulate a fundamental trend. The caliber of teaching directly impacts the trajectory of our educational endeavors. Yet, in this age of rapid technological advancement and cultural transformation, what constitutes quality pedagogical activity is subject to continual reevaluation. That we are compelled to ponder what should a teacher of the new era be like, what qualities and attributes are essential for navigating the complexities of contemporary education. It is within the context that the concept of innovative culture emerged as a guiding beacon. Analyze and generalization of a result of methodological, pedagogical, and methodical research on the problem of training future teachers to use ICT in teaching allows us to conclude that the teacher's activity not only doesn't become less important and meaningful, but moves in the new environment to a new high level of significance. I have tried to answer the following question. How to improve the system of training future physics teachers to design and organize students' learning activities in the information educational environment. Considering the educational activity as a social process, where the qualitative results is significant for all stakeholders of education, in this study, I use the methodology of rapid foresight. Rapid foresight is a strategic planning technique that involves rapidly anticipating future trends and changes. In the context of teacher education, involving students in this process can provide valuable information and perspectives. The study involved a total of 12 students who participated in a collaborative and iterative process of identifying key areas for improving teacher preparation. The purpose was to use the ideas and perspectives of the students to identify areas for improving teacher education. This group utilized a rapid foresight approach that included activities such as focus group discussion, brainstorming session, and collaborative workshops. Foresight research technology has become an essential element in the field of forecasting the future. The main idea of this technology is the joint creation by all participants of a foresight session of so-called time map, which is formed on the basis of their work with images and schemes. Future map is a visual representation of the overall future, including key trends, events, technologies, strategic crossroads, and decision points in the educational sphere. It becomes a final product of the foresight session. That, unlike other methods of forecasting and planning, the result of a foresight session is a map of the future created on the basis of the opinion of its participants. Structurally, the map of the future is a table placed on the large sheet of paper for better visualization. It contains 3 columns corresponding to the 3 event horizons, near, medium, and long range. And each time horizon spans 5 or 10 years with the participation of the moderator. Participants place cards on the map of the future such as trends, technologies, opportunities, threats, etc. Gradually, an image of the future is formed, which is projected within the framework of the foresight session. The rapid foresight study included the 6 steps in the course of the group work. The task of the step is to clarify the subject of the work, the focus of attention, the boundaries of consideration of the subject, and the topic of discussion of the foresight session was information technologies in the physics lessons. The task of second task is to create a description of the environment, directions, and the dynamics of its change, as well as the factors affecting it. The essence of work during the task is to place on the map of the future trends, the main trends increasing or decreasing their influence on the subject area. Participants identified the following trends as presented on the slide. The task of third step is to define the list of participants operating in the space of the foresight object and topic. Subject identified by the participants, students, teachers, parents, and school management. The task of next step is to identify and understand realistic and plausible situations that either open windows or opportunity for them or destroy the possibility of existence and action in the given foresight space. Participants named threats and opportunities for the selected subject, some of which are shown on the slide. Threats are shown in red, opportunities in orange. For example, gaming and social media can cause addiction, which is bad for learning and health for students. And ICT enables the creation of interactive learning materials that make learning more engaging and comprehensible. It's opportunities for the students. The task of fifth step is a detailed saturation of the described environment with elements of activity and understanding of how exactly this activity is released. ICT enhanced learning formats can be adapted to meet specific educational goals and needs, and their choice depends on the context and learning objectives. For example, online courses allow students to learn subjects and topics through interactive materials, video lectures, exercises, and tests available online. Information and educational resources that were highlighted by the participants of the foresight session, electronic simulations and virtual laboratories, video lectures, presentation with interactive elements, educational websites, educational groups or forums on popular social media sites, mobile apps designed for learning physics, and gamification, data analytics, and artificial intelligence systems. Participants noted the need to develop a cyber security strategy, ensure equal access to technology, caution against misuse of technology, and teach students digital literacy. In conclusion, the participants of the foresight session formed an image of the future that meets the expectation of the group, and the use of ICT in the classroom will continue to develop and evolve in the future. The pedagogical study employs the foresight method yielded insightful results by gathering diverse opinions on new trends in education and technology. The study involved participants from various educational backgrounds, and the foresight method facilitated a forward-looking exploration of emerging trends. And in this slide, you can see the key findings. In conclusion, the pedagogical study using the foresight method successfully captured a spectrum of opinions on new trends in education and technology. And further research will focus on the following aspects: how future teachers' participation in a foresight study analyzing trends in physics teaching affects their academic achievement and future professional activities in education. What is the influence of discussing these issues on students participating in focus groups? And further research in these areas will further our understanding of the impact of educational research in shaping future teaching practices and educational strategies. Thank you for your attention. And if you have any question, I'm ready to answer.
Okay, we thank you for your presentation and for your presentation online, because it's very
Nice.
oh, yes, no, it's very nice. It's very good for today, for our. Okay, thank you. Are there some questions?
I get him. Do you work in university? Yes?
Yes, yes.
And do you have only learning content management system for university education? But or maybe in different university using different learning content management. Moodle classroom or other digital platforms.
Technology.
Okay, thank you for your question. In Kazakhstan, in our university, we have an academic freedom, and we
Yes, in Ukraine.
And we choose the educational platforms, and we.
But in your university, all of the teachers using one platforms or not?
So teachers choose their platforms, when they teach.
Not university platforms for all the courses.
No.
Okay. But what we study, online or distance? Offline?
Offline, and
Okay.
we have educational programs that teach in distance.
Okay.
When during the quarantine, what platform did you using?
Google Meet platform, Zoom platform, Google Meet.
But you in your university don't using learning content management systems.
We have the learning management system, but teacher choose the educational platform or educational books. Teachers choose.
Teacher, okay, some stuff, yes, choose. But university don't have one platform for all teachers, not?
Yes. We don't have one purpose.
Okay. Okay, I see. Okay, what physics might be a special program, especially for physics subject, especially Apple's programs do you use?
Apple programs.
Only, okay.
Apple programs, yes.
Yes. Okay.
We have we use mobile apps in teach and artificial intelligence. When we teach, we use artificial intelligence in our lesson for in our subject.
Okay, it's used as some self-work, yes, for student. It used in the home, yes?
Yes.
Yes, okay, I understand, thank you. Are there any question? Please, if you have questions, you can write or say. Okay. Thank you. Thank you. And we sent a message, hi for Kazakhstan.
Thank you.
Thank you. And next report. Next report is from some teams. Ілона Бацурковська, Наталя Доценко, Олена Горбенко, Антоніна Галеєва, Вячеслав Курперін. Online control of educational result of the unit electricity in the condition of blended learning. Please.
There is presented online control of educational results of the unit electricity in the conditions of blended learning. In connection with the pandemic and the introduction of martial law in Ukraine, there is a need to modernize the education system. The practice of using blended or distance form of learning dominates. Forms and methods of education are being improved, new technologies for learning and providing educational content are emerging. In particular, during the studying the unit electricity, in the context of studying the discipline physics, there is a need in assessment of its quality. During remote stages of education, reverse communication when receiving information in an online format becomes an actual issue. Also, it's necessary to be noted that any submission of information must be monitored for assimilation of higher education applicants. The main requirement for countermeasure of the activities of higher education applicants is the professional focus of monitoring the conditions of distance learning. In order to achieve the objectivity of control in the conditions of distance learning, the requirements of informativeness, the validity and reliability of control, differentiation of verification should be followed. The research methodology involves the analysis and synthesis of scientific, pedagogical, methodological sources and empirical methods, as well as the analysis of the obtained results. Before the implementation of the developed technology and after the completion of the experimental work, the study was conducted. It included an analysis of the quality of knowledge of studying the specified topic. The obtained results before and after the experiment were tested using the Pearson chi-square statistical test. There are presented the technology of online control of educational results of the unit electricity in the conditions of blended learning. The unit electricity consists of the three topics. It is electric field in vacuum, electric field in substance, and electric current. For each part, there are outlined the topics. For example, in the first part, electric field in vacuum, there are outlined electric field strengths, potential, the connection between tension and potential, electric dipole, circulation and flow of the electric field. For realization, the online control of educational results of this part of the unit electricity, there were used the graphical, the calculation, the audio, and the animated questions. Second part, electric field in substance, consists of the topics about electric field in dielectrics and conductors in the electric field. To realization this part of the unit electricity were used animated and graphical questions. And in the part of electric current, there are used topics general laws of electric current, electric circuit, current in a circuit with a capacitor, and work and current power. And for its realization were used audio, graphical, calculation, and animated questions. At the end of realization, the online control of educational results of the unit electricity, there are presented final test and control work of the unit electricity. Here you can see the examples of the different types of the tests in the context of the unit electricity. The calculation test can vary in complexity and may cover different areas of science. The purpose of a calculation test is to measure a person's numerical responding skills, problem-solving abilities, and mathematical fluency. The students must compute then input the numerical response. With the use of the following type of tests, applicants of higher education can improve their speed calculation skills as well as their understanding of theoretical, technical, and mathematical domains. The audio test is a control measure that involves fixing the level of knowledge acquisition at a given interval of mastering educational content. The essence of the audio test is that the student has opportunity to listen an audio question and options for possible audio answer to this question. After listening, the students choose the correct answer. Audio tests are relevant in the educational process due to the fact that modern students prefer audio files to text and even video files. Therefore, the development of this type of test tasks must necessarily be accompanied by modern audio-visual content. The use of this type of tasks prevents mechanical selection of the answer, activates memory, and the degree of assimilation of educational content. The usage of graphical tests aims to develop professional competencies through the training of visual perception and work with engineering drawings, diagrams, and other graphic objects in the conditions of blended learning. This type of test offers a chance to deep awareness of certain process and technical system within the complex, serving as an addition of the theoretical study of teaching materials, practical applications, and laboratory work. Tests that allow to drag a visual picture into a text or visual picture into a picture allows to analyze and distinguish between different engineering machine components or, for example, different physical terms and concepts. This type of test can develop analytical skills, memory training, and visual perception training. Based on the GIF animation of physical processes, an animated test is presented. It is required to select one of the suggested images in order to restart the entire process. The processes of simulating the physical interaction of solids, the motion of particle, liquid, and gas systems, the simulation of dynamic motion, and the spatial animation of geometric forms may all be seen in animated simulators. It makes possible to carry out physical investigations that need some specialized equipment and comprehend their working principles. There are presented the levels of studying the unit electricity during blended learning in the control and experimental group at the beginning and at the end of the experiment. The obtained empirical value of Prislinski square test at the end of the experiment is more or equal than the critical value, which means it's belonging to the zone of significance. The level of studying the unit electricity during online learning in the control and experimental groups at the end of the experiment have significant differences, and it's obvious that the author's technology is effective. Online control of educational results in the unit electricity within a blended learning context offers numerous benefits, including flexibility, accessibility, diverse assessment format, real-time feedback, data-driven insights, authentic assessment opportunities, academic integrity safeguards, supporting for diverse learners, and increased engagement and motivation. However, it's essential for educators to thoughtfully design and implement online assessment to maximize their effectiveness and ensure they align with the learning objectives and needs of students. The implementation of the proposed technology contributed to the improvement of the quality of students' knowledge and skills on the unit electricity. Analysis of the results of the experiment using the Pearson statistical test showed a statistically significant increase in the level of educational results in the experimental group compared to the control group, which confirms the effectiveness of the developed technology. Thank you for your attention.
Thank you, and you?
Hello to
Yes.
everyone. Hello to the conference chairs, to the conference participants, and thank you for the opportunity to take part in such interesting conference. So let's discuss.
Yes, yes. Thank you, and you. It's your work. It's very important for in our times, in our country, because we all study, not all, but most of our students study offline, online, and distance. Okay, thank you, dear colleagues. Please
I have a question.
start. Yes, discuss.
On your slide, you show that you use audio format in the question. Did you think that it's more useful than text format?
Okay, thank you for your question.
Because student can have problems with audio file or not.
Thank you for your question. I would like to mention for that audio test, it is just one of the type of the test, yes, but in the context of the modern students, you know, they often prefer to use audio files to send audio messages. Sometimes it can be inconvenient, but they prefer this. Before our experiment, we make some self-assessment for students for how for them different type of tests convenient or inconvenient, and they choose that audio test have a great percentage of their conveniency.
Thanks. And what's difference in the learning process in your experiment? Only in stage control or stage education? Only stage control.
As a control stage, we can see that there is no significant differences between the educational results and in the experimental stage. When we develop the proposed technology, we can see that the experimental group choose to learn according to the proposed technology, and control group choose to learn only by the traditional scheme. And at the end of the experiment, we can see the great differences in the results according to the levels of of knowledge. For example, at the A level, the best students before the experiment in the control group have the 2% and in the experiment group also around 2%. And after the experiment, the students of the level A have a difference in control group 5% and in the experimental group 11%. If we want to talk about students with lower level of knowledge, for example, the level D, let it be, before the experiment, in the experimental and the control group, the levels almost equal, and after the implementation of the proposed technology, the levels differs, and the differences between levels, especially we can see in the levels A, B, C. So students who have good marks, good points. Thank you.
Thank you.
And we have a question in the chat. At our university, we can read out the exam results of a massive open online course as part of our courses. In case of complaints with the topic, the name of the discipline, do you have such an experience?
Yes. We have such experience in our previous articles. We show this problem massively. So for example, we can take some parts of massive online courses. It can be lectures, it can be tests, it can be according to the topic, according to the discipline, and we integrate it into the curriculum, integrated into the working plan of the program, and then our students can use that. We have, of course, we show the references that students use the materials of massive open online courses. And it is also quite a good practice, not only our developments, but the developments of authors who form these courses.
Okay.
Thanks. Can there be a situation when students learning similar course, online, massive online course, and we must we must count credits from the massive course for all your course.
No, we take just elements of massive online courses, some lectures, some online tests, not all the courses.
How many hours you use for online course?
Can you repeat, please?
How many hours no? What course of your use and how many hours in this course?
Okay, I see. You know, we try to at the first stages, yes, we try to use different online courses on the online platform of the Khan Academy, Udacity, University, but in my opinion, probably it's only my personal opinion, the Coursera have quite good courses. There are we can use the elements of lectures of the worldwide scientists, and there are also have good examples of practical tasks. Now I'm talking about technical disciplines. It can be used in the context of physics. I use it in the context of disciplines that I read in my university in the context of mechanics of materials and constructions, and there are interesting, modern, and very usable and accessible and understandable for students elements, despite the fact that that courses are presented by the worldwide scientists, professors, etc. But it is very useful too. Thank you.
Okay, thank you. Irina, do you have questions? Any questions?
Thank you.
Okay, thank you.
Thank you.
And next question, reports, yes, it's Vladimir Velichko, Kaklan, Kaldan, and Fedorenko analysis of computer simulation tools in educational and research context. Please, Vladimir.
We see that your presentation have other name. This is presentation.
Okay. Sorry.
Yes, it's our presentation. Yes, it's our presentation.
In the educational process based on the example of studying Coulomb's law. Modeling can be used to study a variety of objects and processes, from climate change to the behavior of physical systems or economic phenomena. It allows us to analyze complex relationships and conduct research in conditions where real-world experiments would be difficult or dangerous. In education, computer modeling defines an activity-based approach to learning and development. Virtual laboratories, simulations, and interactive exercises provide an opportunity to create a realistic learning environment where students can experiment, solve problems, etc. In scientific studies, computer modeling plays a key role in solving various problems and studying complex systems. Modeling expands the possibilities of experiments, allowing the study of phenomena that would otherwise be difficult, costly, or impossible. Thus, the current position of computer modeling in scientific research demonstrates its key role in advancing knowledge and developing the scientific field. Implementation is performed using various tools. For this purpose, you can use a variety of instrumental software tools and environments: MathCAD, MATLAB, Maple, WizSim, Genius, etc. The advantage of using mathematical packages is that they can be used as ordinary calculation tools, tools for simplifying expressions, and tools for generating graphics and sounds. The means of interaction with the Internet, which are realized by generating HTML pages directly in the process of calculations, have also become widespread. A qualified user who knows at least one of the programming languages can create the required program or even a whole set of programs independently. However, this approach usually requires a lot of labor to program, debug, and test each program, so to save time, it is advisable to use the specified application software packages, the areas of application of which largely overlap. In software packages for simulation modeling. Simulation modeling is a research method when the system under study is replaced by a model that can describe the real system with sufficient accuracy, and this model is used to conduct the necessary experiments, the purpose of which is to obtain information about the system. This type of modeling is used when it is not possible to experiment on a real object, build an analytical model, or create a simulation and track the behavior of the system in real time. This type of modeling is the most effective when designing and analyzing production systems, determining requirements for equipment and communication network protocols, modernizing various processes in the business field, etc. The most popular simulation modeling packages are shown on the screen. To make the review more substantive, let's define a topic from the school physics course, Coulomb's law. Simulators that can be used in school physics courses cover a significant amount of educational material. The most well-known collections include PhET, Lab Exchange, Concord, Praxilabs, Labster, Merlot, Physics at School Kit, and so on. For organizing and conducting e-learning and for self-education. The simulations presented here also include simulation for the topic we have chosen. It is clear that each simulation represents an appropriate methodological approach to the study of Coulomb's law. This can be demonstrated on physical devices or on imaginary objects. In any case, the choice of a simulation depends on the prevailing teaching technology and the availability and accessibility of simulations for use. The analysis allows us to identify some intermediate results. The possibilities must include realism of the created models, interactivity and the availability to conduct such experiments, and flexibility of model parameter settings. Spreadsheet processors are not only a tool for calculating accounting spreadsheets. Spreadsheets are an excellent all-purpose tool for calculating, storing, and analyzing results. They are more suitable than any other application software as a platform for computer modeling. Spreadsheets are available both as desktop programs and as services. Popular spreadsheets today include Microsoft Excel, LibreOffice, Calc, OnlyOffice Spreadsheet Editor, WPS Spreadsheet, and others. The above examples are also available for mobile platforms. Among the cloud services, it is necessary to mention such resources as Google Sheets, Microsoft Excel Online, Zoho Sheet, OnlyOffice Spreadsheet Editor Online, and others. Most of them are available under free licenses or licenses with some restrictions. Thus, we can state that there is a significant list of available spreadsheet processors for secondary education, and the issue of their availability is not currently an issue. Of how spreadsheets can be used when studying Coulomb's law. First of all, we can show in practice what a direct relationship and inverse relationship are. To do this, it will be enough to calculate the value of the force of interaction between charges at constant values of charges and a variable part of the distance between them. Using the obtained values, we will construct a line graph and demonstrate that the graph will not be a line. Second, we can demonstrate whether the charges will attract or repel at different values. To enhance the visualization, we can use conditional formatting. Systems are as useful a tool for computer modeling as spreadsheets. The ability to store data, calculate various values, including through the use of programming elements, built-in functions and additional modules, make it possible to consider these systems as a full-fledged implementation of a computer model. The available data visualization tools and the absence of a workflow, which is surprisingly important for the research, indicate the advantages of computer algebra systems in modeling. The caveats include the need to master the systems at the level of a confident user, since each of them has its own specifics, set of commands, etc. The computer mathematics package, Scilab, is an excellent tool for conducting research that requires calculations. This package can be applied in our case. Despite the fact that the system, as already mentioned, requires some knowledge, its consideration is already included in the curriculum and relevant textbooks on computer science at the secondary level in Ukraine. We can define either a simple variant of calculating the value of the interaction force according to Coulomb's law, or a more complex variant for an array of values, and then experiment with the parameters. Academic freedom, each teacher is not prohibited from using not only different methodological approaches to teaching, but also the choice of teaching aids. It is clear that not every teacher will create their own implementations of the computer model, but this is a possibility and should be included in the comparison of computer modeling tools and methods in secondary education. To implement a computer model without using existing general and specific purpose application software, knowledge and experience in programming are required. Moreover, this experience should correlate with the student's programming experience, because it is one thing to demonstrate the created model when familiarizing the material in general, to provide students with the opportunity to experiment with the implemented computer model, including during self-education activities, is a completely different issue. If we look at our topic, Coulomb's law, we can create an application in Object Pascal that will calculate the value of the interaction force for the entered values of the charges and distances. In addition, we can plot the dependence of the interaction force on the distance between the charges. To visualize the interaction of the point electrostatic charges, power lines are usually drawn to show how the charges interact with each other. For such a visualization, one can also use the Python programming language using appropriate libraries or ready-made developments. To combine the analysis of the impact of the use of computer modeling tools on the results of educational activities with the analysis of the results themselves, which depend on the purpose of the educational process. These results depend mainly on the level of education and profile. To a certain extent, the results of studying physics at the level of general education, vocational, professional, pre-university and higher education are united by the fact that as a result a single physical picture of the world should be created, which is a prerequisite for the formation of scientific worldview. In addition, the structure of ideas about processes in the world around us is formed, which allows us to form technical thinking, which in turn helps us to adapt to the current pace of development of science and technology. However, depending on the chosen profile of the study, the depth of such a technical outlook will vary. It is logical to conclude that the amount and depth of knowledge gained depends on their chosen future specialization, and this allows us to assert that the range of knowledge should range from the level of possession of information about how the world around us works to a complete understanding of all laws and processes with the ability to independently analyze and synthesize information and apply the acquired knowledge. Thus, the use of computer modeling tools should also correspond to these limit cases. We used the expert method to evaluate the considered modeling tools for studying the interaction between charged particles. We had two groups of experts, Donetsk, Khmelnytsky and Odessa regions. The first group consisted of professors and teachers of physics, and the second group consisted of students and pupils. Physics teachers and professors and 72 students took part in the survey. The results of the survey are shown in Figure 8. The majority of teachers and lecturers agree that e-learning resources are a useful teaching tool. Teachers expect computer modeling to be interesting for students. Teachers agree that it is a useful method of both problem solving and cognition, but they are not willing to take the initiative to promote it themselves. For students, new things in physics class are always interesting, and therefore they are happy to use electronic educational resources. The majority of students agree that e-learning resources are useful for understanding the material. Only a third of the students perceive the computer modeling method as interesting and useful for learning, and only 6 students out of 72 are ready to continue self-educational research activities using the computer modeling method. It's almost identical in the opinion of both teachers and students. The highest rating was given to the off-the-shelf simulators because they are bright and ready to use. The lower rating was given to their own developments in programming languages because it's programming, so it's difficult. A comparative analysis of modeling tools has shown that mathematical packages are the most functional and convenient for use in educational process. At the same time, off-the-shelf simulations also provide opportunities for modeling, although they are not as versatile. General-purpose application software, in this case spreadsheets, is suitable for using modeling as a method of solving problems and improving research competence. Attention should also be paid to the use of programming languages in computer modeling, despite the fact that it is necessary to have appropriate programming competence. Thank you for attention.
Thank you. Okay, Vadim, I see you. Okay, I see you agree to discuss. Yes, yes, speaker.
Yes.
Yes. Okay, dear participant, there are some questions because it's very interesting and experiment and very interesting interview on educating, teaching, and students. Okay, are there some questions? There are, yes, but I will speak. I want to question you. Not question. I ask you. You say that you programming your student programming column law, yes?
My
Or
student
maybe
used
different.
more simulation.
Okay,
It's
simulation, yes.
first year education of college, and they used simulation.
Okay, I see. Use simulation. Only column law or different.
We used more simulation. It's mechanical, electricity, properties of substance, and one of the circuit construction simulation.
Okay, I understand. Thank
All
you.
course of the physics of first and second year education.
Yes. Do you have basics? Not basics. Do you have basic? Maybe you have a list of this simulation on your site, on your site of your university, where you can find.
We have some text for this simulation, but we used simulation font others no education system, and we use simulation with the University of Colorado. We don't use at our Moodle. We used it on the lessons on the homeworks for help of main learning process.
Okay. Thank you. I see. Okay. Are there any questions?
I think that it was a very interesting result that your students have a very percent for the first question. Should we use electronic educational resource in the process of learning physics? Compare with teachers.
Okay.
Teachers says because practice. We and the students we no they want to use at elements of gamification of education.
Yes.
Yes. Okay. Thank you, Vadim. Maybe anybody want to say anything here yet? No, yes. Okay, and next report.
Thank you for your questions.
Yes, and the next
Thank you.
report we have in live format, and
Okay.
Svetlana Malchenko
Yes, it's me.
starts to present.
Okay. Yes, it's me. One moment, please. I don't see. Sorry. Do you Okay, I have some problems because, okay. Yes. Okay. Thank you. Yes, my topic is the use of visualization technologies in the study of the probability of life on exoplanets. I have small teams. It's with me, David Mikolyuk and Sergei Salivon. They study one study studied in the Kryvyi Rih State Pedagogical University. Okay, today the modern generation resolved the information from various sources, which must be quickly analyzed and critically evaluated. Okay. Visualization of information is another future of young people. Accordingly, modern digital and visual technologies should be used in education. Using the latest technologies promotes the development of the analytical and critical thinking. Visualization's main future and advantages are its simplicity, stability, and high perception speed. It performs the following main function of educational: informative, communicative, cognitive, interaction, aesthetics, and illustrative. Teaching natural sciences, specifically math, physics and astronomy in a modern school is a basic for forming a modern scientific worldview in students. Understanding the importance of the basic physical and astronomical concept and laws for solving the practical needs of society and developing students' intellectual abilities and cognitive interest. Astronomy is an observation science, but with our on Earth, we can't see all of object in the university. We can see only low part of this object. So every day in internet is constantly filled with information about discovery and Earth-type planets outside the solar system. Of course, the question immediately arises: wherever life can exist on the new exoplanet. On the lesson, we must study pupil for answer for finding for these questions and these questions and answer on this question. Astronomy teacher needs to use visualization technologies that allow them understanding basic astronomy concept and well-known forms such as presentation, posters, animation, and videos. More interesting digital technologies allow for observations and influence in astronomical phenomena such as interactive simulation and mobile phone or computer application. The study of the exoplanet was offered in astronomy classes to students of the specialty secondary educational physics and astronomy, and for scientific students work. We used for this such as program as Universe Sandbox 2. One of the function of the Universe Sandbox is a study of exoplanet and conditions necessary for life to exist on them. The application based on the certain physical characteristics, radius, density, speeds, and surface temperature measured the percentages of similarity of an exoplanet to Earth. It also measures the probability of life on planets as a percentile based on compared Earth properties necessary for life as we know it. Inhabitable zone is shown in green. The inner part of markers in red, corresponding to high temperature in this area. And the outer part is in blue, indicating habitable zone and how factors such as liquid water, magnetic field, and atmospheric effects the probability of life on them. The purpose of practical tests for students is to model and investigate a system for the possibility of life on the planet belonging to this system using the interactive simulation Universe Sandbox 2. The results are given on the slide. Next slide in the table on the graphic. As you can see from the slide, habitable zone increase with increase the star's mass. And with a decrease in mass, the habitable zone decrease. This is the size of habitable zones is directly proportion of mass of the star. The same conclusion were obtained for the star's luminosity. Note that at mass 1.30, solar mass in the habitable zone disappears. This is explained by the fact that luminosity and temperature of the star also depend on its mass. We study some stars. Also, you can see a result of our experiments for Kepler 186. Next, the second task in the proposed practical work is analysis of the conditions for life on the planets. Changing the physical characteristic values of the exoplanet in the star's life belts is necessary to accomplish this useful task. Using the software's Universe Sandbox 2. The result you can see on that slide. We used different planets and different planet system with some famous stars, Kepler 2028, Kepler 62, TRAPPIST-1, Gliese 667, and K2 18. These planets orbit stars of spectral times Chi-M and have maximum life belt. At the beginning of the study, these planets were outside the habitable zone, but we changed some physical parameter and probability of life existence was increased. The result presents on the table and as a conclusion, after completing the following practical tests, student must be Earth mass explains located in the life belts of their stars are most likely candidate for habitable. Exoplanet with strong magnetic fields may be more protected from harmful radiation from their stars. Exoplanets with dense atmosphere may have more stable surface conditions than planets with thin atmosphere. And in conclusion of our work, we can say that Universe Sandbox is a great tool for simulation and modeling various objects in the universe, such as planetary systems, galaxies, and other celestial bodies. It offers the ability to manipulate gravity, time, and other cosmic factors, providing using with highly interactive and educational experiments. In this work, the application is used to implement interactive visualization of practical tests in astronomy, namely how the physical parameter of stars and planets affect the probability of life's existence. Interactive simulation are important visualization tool that helps solve problems and implement practical tasks in school, making them more exemplar and closer to fundamental scientific research. As a result, students have a better understanding of the law of gravity, methods of searching for exoplanet, and the physical parameters of star and their exoplanet, which affect probability of life on found exoplanets. Okay, it's all my report. Thank you for attention. Thank you for your time, and please give your question.
Thank you, Svetlana. And I think that astronomy it's a very interesting study, but traditionally for study astronomy in the secondary school always very small count hours.
Yes. Yes, it's small, but in Ukraine future, I hope the astronomy questions was studied from the secondary school, not only high school. It was studied from 7th class with a course of physics. But astronomy really is have many times for study in this modern school. We used this program only for scientific works for pupils.
Thank you. Did you realize your research for future teachers physics?
Yes. It was most for the future teachers of physics and astronomy in the Kryvyi Rih State Pedagogical University.
Thanks. And what equipment do you have in Kryvyi Rih State Pedagogical University for study astronomy?
Equipment?
Special equipment. Without simulator.
Yes, I understand. We used different simulator, different apply. We used IR, VR, apps for mobile phone. But now we study distance. And we used Learning App, we used Kahoot for control their knowledge. And such as practical test, we used only low count. I used Universe Sandbox. Yeah, I used DAF Moon. I used some other programs for mobile phone.
But now we see that behind you have equipment for study astronomy, Pani Svetlana.
I'm sorry for.
Behind you.
Oh, yes. Yes. Yes, behind me, it's a new electronic telescope. It's because before conference, I speak with not future teacher. I speak with my it's with a teacher, and I presented this telescope, this new telescope, electronic, for there, and we have not lesson, but we used the telescope in the additional meeting with my students, today student or future student, or student in on the student, no, student on the teacher. Yes, it's a telescope named Universe.
Thank you.
It's modern digital telescope because it have applied and they control only phone, not not on
additional
hand.
equipment.
Yes.
Thank you.
But it is my future report on the next year.
And it was the last present, last report.
Okay, yes. Okay, so we can finish it today, but not, we can finish it our section, but not conference, because half hour ago start another section. And you can go to another hour section on the science educational. It's
Okay, thank you very much.
our.
We would like to thank you very, very much for the hospitality here, and we will go to the other sessions. Okay.
Okay, we thank you for your with us for ending, because I know time of in you country. So from Philippines is here.
We invite you present your research in next year, and we very happy that we have participants from last year.
Yes.
It would be good. It would be good.
Thanks.
Thank. Be with us and next year.
And today in Ukraine we have a embroidered day, and our participants from Ukraine, Svetlana, Irina, Vadim, and Natalia, have short
Ah,
pleats.
yes.
Yes, we have a special wear.
Special day,
Uh-huh.
так. Yes.
Yeah, okay, okay. Good. That's good.
Thank you.
Thank you for your attention.
Mhm.
And
The
Good
ending.
afternoon to everybody.
Good,
Bye.
good afternoon.
have a good day.
Yeah, bye. Bye.
Bye. And
Goodbye.
glory to Ukraine.